All right, so this is day 2 of variation functions. So our essential question is, how do I use inverse and combined variations to solve problems?
So last lesson, we talked about direct variations. Today, like Ms. Boyd said, we're going to change it up a bit and talk about inverse and combine. So it says a third type of variation describes a situation in which one quantity increases and the other decreases. I know it says a third type because if I recall, last lesson we talked about direct and joint.
Right.
Okay?
Okay.
So that's why we're calling this now a third.
Okay.
One quantity increases and the other decreases.
So if we look at this, these are going up and these are going, well, yeah, let me redo those arrows. As you go down, they're increasing.
Yes.
I'll just do a plus.
Yeah.
And as these go, they are decreasing.
Exactly. And so with direct, one goes up, the other goes up. Okay, so that's the difference here with inverse. So, and it says right here, the table shows that the time needed to drive 600 miles, the time decreases as speed increases. That's common sense.
Yeah.
The faster I go, the less time it's going to take for me to get to my destination.
But don't speed.
No. This type of variation is an inverse variation, and the formula for inverse is y equals k over x. That says y varies inversely as x.
Gotcha.
Whereas yesterday it was y equals k times x. Okay? But we're going to do the
So
same.
then we just do the opposite operation.
Right. So we're going to get a problem where we find no x, we know y, we solve for k, and then we rewrite it as an inverse variation function. And here we go. We are given y varies inversely as x. The minute you hear that, you're going to write exactly. We know y is 4, we know x is 5. So let's write the function and graph it.
Okay, so y is 4.
Mm-hmm.
We don't know k.
Mm-hmm.
And x is 5.
Mm-hmm.
So now we just solve.
Correct.
So multiply both sides by 5.
Yep.
Times by 5.
Right.
And we get 20 equals k.
Correct. So we know our k now. So now we plug that back into our original function.
Okay, so we get y equals 20 over x.
That's our answer. So let's circle that. Now, or highlight it, yes. To graph, you have a couple options. I would highly recommend using a calculator. It's so much easier. You can plot points if you want. So the graph, Miss Boyd, is going to look like this.
So it's going to look like this if you use your calculator.
Correct.
And
And notice we're not doing exact points it goes through. We just want to see that you have an idea of where it goes. Whereas a direct variation, it's much easier to graph because it's a line.
Right.
So like I said, you can plot this by hand by making a table.
Yeah, you can make a table.
Yep.
X, Y's.
So yeah, right. If we had x equal to 1, y is 20. X is negative 1, y is negative 20. And I did x is 2, y is 10.
And you only usually need 3. Oh,
well,
not
this negative. I would do one more. I would do negative 2, which is negative 10.
Good.
Okay, that's enough. It gives you an idea, but I would use a calculator,
Okay.
graphing calculator. Well, I'm wondering if, like we did the last time, if we should save
let's
this
skip one.
and do that in class.
Perfect.
Okay, so that's that. So we go to the next page. Oh, yes. Let's do this one.
Okay.
The time t that it takes for a group of volunteers to construct a house varies inversely as the number of volunteers v. If 20 volunteers can build a house in 62.5 working hours, how many working hours would it take 15 volunteers to build a house?
Okay.
So inversely, we know is what? Y equals
k
over x.
x.
However, we're not using these variables. So now t varies inversely with v. And notice the wording. The time varies inversely. I know it says as. That sounds weird, but that's the way they word it. T varies inversely as v. So the as, after the as, that variable is on the bottom.
Got it.
Okay? All right. Well, we know there are 20 volunteers. So we can plug in 20 for v. And we know t too. It takes 62.5 hours.
Okay.
So we can solve.
So we
Multiply both sides by 20. And when we do that, we get 1250 is equal to k. Now let's plug that back in. So we
Okay.
have T is equal to
Equals
1250
1250.
over V.
V.
So now look what it's asking. How many working hours, so we want to know T,
Right.
would it take 15 volunteers to build a house?
So we just plug it in.
Right.
So T equals 1250
Mhm.
over the 15 is how many volunteers?
And when you divide that, you get 83.3 hours. And we're done.
Great.
Mhm.
That's easy enough. As long as you know how to set up the original formula.
Exactly. So this is just kind of a refresher.
Mhm.
Let's see. Oh, I know why we're doing this. Okay. So you can use algebra to rewrite variation functions in terms of k. So we always know direct variation is y equals k times x.
Mhm.
When you solve for k,
Get
you
K by
divide both
itself,
sides by
you divide
x,
by X.
and you look at the ratio. For direct variation, k is constant, meaning the ratio of y over x is constant.
Okay.
Inverse variation, same thing. You start with y equals k over x. Solving for k, you multiply both sides by x, and then k is equal to x times y.
Got it.
So that means the product is
Right.
constant. So
Okay.
let's see what this says below. Notice that in a direct variation, like I just said, the ratio is constant.
Fraction.
Mhm.
Mhm.
In inverse variation, the product, the
Multiplying.
multiplication. So that's what you have to look for. Students get confused because they're used to inverse being a fraction,
Right.
direct being a not a fraction.
Right. So it's the
However,
opposite kinda
when
when
you're
you're solving for
you're
K.
solving for k, it's you're just
It
thinking of
flips
it,
it.
it's the flip of it.
Okay.
Okay? So on the next page, we have an example.
All right.
We are going to determine whether each data set represents a direct variation, an inverse variation, or neither.
Okay.
So the first thing we need to do is we need to calculate the ratio
Right.
and the product for each one. So let's start with A,
Okay.
okay? So
Got
let's start with ratio.
All right. So ratio would just be X over Y.
Yep. So let's do that. So,
6.5 over 8.
right. And do you want to show that work, or should I just say
You can
it?
just tell me what it is, I guess.
Because, yeah, see, we only have so much room. See
Yeah.
what I'm saying?
That's okay.
You want to
I'll
leave it?
just do this one this
Okay,
way.
1.23.
Okay.
And then 13 over 4 is 0.3.
Oh. Gotcha. I was just going to write the answers now.
Okay. 13 over 4 is 0.31. But guess what? We don't have to do the last one. Do you know why?
Because they're not the same.
They're not the same.
Yeah.
So we know it's not going to be a direct variation. So now let's do x times y.
So inverse.
Yep, x times y would be the inverse. Remember it's the
Opposite.
flip-flop when
Okay.
because we're looking at the
So
k
you do
value,
6.5 times 8.
which
and
is
we get
52. And then 13
13
times
times
4
4
is
is
52. And 104 times 0.5 is 52.
Oh.
Because the product is constant, that means it's an inverse.
Got
So
it.
maybe next week, because let's
I'm
write
gonna write inverse
yeah.
on top.
it's an inverse variation. That's
That's my arrow.
that's perfect.
There we go.
Now let's do B.
All right.
Same
So,
thing.
Direct.
Oh, we're doing C? Okay,
Oh, sorry.
that's
I
fine.
was just going across.
Okay, that's fine. We'll
so
do
X
C.
over Y.
Yep. So 3 divided by 5 is 1.7. What? Oh my goodness. I'm being
We need
so
to do it the other way.
dumb.
We need to do Y divided by X.
What are we doing?
I don't know.
We got to go back. I'm so sorry, you guys. You're probably wondering, what the heck are we doing?
That's
it's
right.
Y
'cause
over-
We flip it when we're solving.
No,
for-
dear. Y over X.
That's what I just.
I
said,
know,
too.
but we
Oh,
didn't. Do you
I
see?
know. I
Okay.
say it, and
All right.
I'm just automatically.
I'm
keep
so
writing it
sorry,
the
you
wrong
guys.
way.
We are
Y
so
over
sorry.
X.
Okay.
Okay.
So we are taking 8 divided by 6.5.
And you got
That is,
1.23.
I can't believe that didn't even jump out at us. Oh
I
my.
know.
Okay.
All right.
And then we're
So
taking
it's
4 divided by 13, which
Okay.
is 0.31.
Still
Okay.
didn't work.
Now let's go
Now I
back over
need
here.
to
Let's
this.
change that to y over x.
There
There
we
we go.
Y over X.
So we're
Okay.
taking 5 divided by 3, which is 1.7.
Okay.
14 divided by 6, which is 2.3.
Oh,
We can stop. They're not the
same.
same. Now let's do inverse, which is
So
the
we
product.
Multiply them.
So 3 times 5 is 15. 6 times 14 is 84.
Stop.
Stop.
So neither.
Yep. That's when you write neither, when it's neither direct nor an inverse.
All
Okay,
right.
last one. Ratio, which is the direct,
Y over
y over x. 30 divided by 5 is
Is
6.
six.
48 divided by 8 is 6.
6.
72 divided by 12 is.
Oh,
So we
6.
can really
We're
stop.
done.
We
This
don't
one's
even,
direct.
yep, we don't even have to check the inverse because it's not going to be both.
Right. They're the
Okay,
same.
it's one or the other.
Great.
All right, so the next one we're going to do in
In
class.
Good idea.
Okay, last part of this lesson. Combined variation is very similar to joint.
Okay.
It's but different. It's because joint is only direct,
Right.
right? This is a relationship that contains both direct and inverse in it.
Okay.
Quantities that vary directly appear in the numerator. Quantities that vary inversely appear in the denominator.
Okay.
So the volume V of a gas varies inversely as the pressure P and directly as the temperature T. So let's write our equation right away.
All right.
So V equals,
Equals.
we need a K right away.
Right.
Always K. Always
Okay.
K is
And
always
it
on
says
top.
It's as P.
So
over P.
inversely over P, but directly as T. So guess where T is? On top.
Oh, that makes
See
sense.
that? So you got to read it. So inversely as P, that's why P's on the bottom, but directly as T, that's why T's on top. Are we good?
Got it.
Okay. A certain gas has a volume of 10. So let's plug in.
Plug it in.
Yep.
10 equals.
And I'm going to scroll down a
Yeah.
little bit for you. And a temperature of 300.
So don't get confused because it's saying kelvins is K, but
That-
we're really plugging it in for
Oh,
the T.
yeah.
as our
That
temperature.
yeah, that can be
So
confusing.
we'll put the 300 here.
And leave the K alone.
Well, I'm not done reading, so I don't know. Let's
No,
keep
we're
reading.
always solving for K though.
All
Okay, we're
right.
always solving for K, Miss Boyd, on the first part of the
All
problem.
right.
Okay. And a pressure,
1.5.
that's the bottom.
All right.
So let's solve. Multiply both sides by 1.5. On the left, we get 15 equals 300K, or K times 300. Divide both sides by 300. And when we do that, we get K is equal to, wait for Miss Boyd here, 0.05.
All right.
There's our K. So now let's plug it back in up
Mhm.
top here. V is equal to 0.05. Oop, 0.05.
Oh, sorry. Thank you.
Times T
Times T
over P. There we go. All right, so now it says if the gas is heated to 400 K, heated
So that's
temperature.
And we're not worrying about the K.
No,
That's just telling us it's
Yep.
kelvins.
so let's plug
So
in
temperature
is 400. We know K is 0.05 still. All over P, which is 1. It says
Oh, yeah,
pressure of
is
1.
Well,
Yep.
let me just multiply those two numbers
Yep,
together.
and when we do that, we get to 20, and it's going to be, I think we're talking liters here. Yeah.
Yes, liters.
Mhm. Is our volume, right?
Yes.
That's it.
All right.
Okay.
Good.
So read those carefully. Next page. Video questions.
All right.
So write the inverse variation function
It varies inversely.
inversely. And then number 2, determine whether the data set represents direct, inverse variation, or neither.
So remember, direct is y over x, and inverse is y times x, or x times y.
Yep.
Okay.
Correct. See you tomorrow.